Consider a coaxial cable of inner radius A and outer radius B as shown in the figure. The relative permittivity of dielectric, the field in between two coaxial cylinders is epsilon r. If we apply a potential difference between the two cylinders, the outer cylinder is uniformly charged with a line distribution of rho L, and the inner cylinder is uniformly charged with the line charge density of minus rho L. So the outer cylinder is plus rho L and inner cylinder is minus rho L. So rho L is the line charge distribution, that is Q by, we can write on it as L. L is, we can write down it as the length of the cylinder, its length, the length. So by applying the Gauss theorem, so we can express the electric field between the dielectric at any point r from the axis of the cylinder. I selected here an arbitrary radius r. The r is any point between A and B. A is the radius of inner cylinder and B is the radius of outer cylinder, and r is the radius of any point between A and B. I arbitrarily selected r to find the expression of electric field intensity between these two points, so A and B. So as per the Gauss law, we can write down E is equal to rho L, which is upon 2 pi epsilon r. Now with this expression, the potential difference between two coaxial cables we can write down as, so we can write down as V minus P by A. Earlier we have studied that potential is an integral function of electric field intensity and the distance. Now if I substitute the expression of E here, this become B by A rho L 2 pi epsilon dr. So rho L 2 pi epsilon we can take it out, so this become minus rho L 2 pi epsilon integral BA dr. There is a term r here. Now integration of 1 by r is the natural logarithm of r. So this become, so if you want to change the minus sign here, you just interchange the upper and lower limit. So this become rho L 2 pi epsilon. The integration of 1 by r is natural logarithm of r. I am substituting the upper and lower limit. Since I interchange the position of upper and lower limit, this minus become minus. So minus of minus become plus. So this become B by A. So this we can write down as rho L 2 pi epsilon natural log of B by A. Because natural log of B minus natural log of A is natural log of B by A. Now the capacitance of coaxial cable per unit length is, the capacitance of coaxial cable, capacitance of coaxial cable per unit length. So what is the capacitance? Capacitance, we know that capacitance is equal to Q by V. Per unit length means we need to divide it the both side with L. So what is Q by L? So rho L is Q by L. So we can write down the capacitance per unit length is rho L by V. So this become rho L. So what is a V? This is V. So V become rho L rho L natural log of B by A 2 pi epsilon. So we can cancel these two terms and we can rearrange as 2 pi epsilon. Epsilon we can write down epsilon naught epsilon r, which is on natural log of B by A farad. This is the capacitance of coaxial cable per unit length. Capacitance per unit length. So we can write down the capacitance per unit length. So what is the capacitance of coaxial cable per unit length is C equal to C. Here is capacitance per unit length is 2 pi epsilon naught epsilon r natural log of B by A. It is a farad capacitance per unit length. So farad per meter. So for obtaining the capacitance of a coaxial cable, you can apply this formula. So here we can see that this formula consists of the epsilon naught epsilon r and outer radius and inner radius of the coaxial cable, which is in terms of the capacitance per unit length. So if you want to find out what is the total capacitance of the complete the cable, then we need to multiply it with length of the cable. So we can find out what is the total capacitance due to the entire length of the cables.